in this video, I'd like to talk about the math question of the day for Saturday, July 15th, 2023. And with this problem, we have this definite integral from a z value of pi to a z value of 0 of the sine of z multiplied by the cosine of z to the third power, all integrated with respect to z. And integration questions like this are typically seen in a Calculus 1 class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through this. And for questions like these, we can try to use some type of substitution. Now, when looking for substitutions, we're looking for a function to replace with a variable, let's say u, and then we need to replace the differential in terms of that new variable u. So we also need the derivative of that function, which we are substituting for. And notice that for our most complicated term, we have the cosine of z to the third power. If we set u equal to the cosine of z, then the derivative of the cosine is the opposite of the sine function. But the main idea is that the derivative, at least up to a factor, is also in the integral. So it makes sense to set u equal to the cosine of z. Since, like I mentioned, if we then substitute in terms for the differential, we take a derivative of each side, we get du is the minus sine of z multiplied by dz. And if we just multiply each side by -1, we move the negative to the other side, then we can see that we can very cleanly substitute for this differential dz and replace it with minus du here. So let's actually carry out this substitution. And for now, I will not rewrite the bounds. We'll put those in a moment. But we have the cosine of z cubed, but we're replacing the cosine of z with u. So now we have u to the third power, and then we're replacing dz, or I should say the sine of z multiplied by dz, with minus du. And we can put the minus sign out in front here. And at this point, we have a much simpler integral that we know how to solve. We can just find the antiderivative of this cubic polynomial using the power rule. We increase the exponent by 1 and then divide by that new exponent. But before we do that, let's put our new bounds onto this integral here. And when z is equal to 0, we can figure out what u is by plugging that in here. The cosine of 0 is just 1. So when z is 0, u is equal to 1. And we can place this bound right up here where the 0 used to be. It will now be a u value equal to 1 for our top bound. And for this lower bound, when z is equal to pi, if we plug that in for z, we have the cosine of pi, which is -1. So u is -1, will be this lower bound. And at this point, we can evaluate this integral by using the power rule. We will increase the exponent by 1 and divide by that new exponent. And then we'll evaluate this at a lower bound of -1 and an upper bound of +1. So at this point, we're just using the fundamental theorem of calculus. Let's do that down here. We have this result here evaluated at the top bound, and then we'll subtract this result at the lower bound. We have minus 1 to the 4th over 4, and 1 to the 4th is just 1, so we get minus 1/4. And then we subtract this evaluated at the lower bound. We plug in -1, and since it's to an even power, the negatives will cancel, and we'll just get +1. So we're subtracting -1/4, which is the same as adding 1/4. And -1/4 plus 1/4 is equal to 0. So this integral is simply equal to 0. And I should mention that if you didn't want to find the bounds for u, you don't have to do that. What you can do is ignore the bounds until the end. Once you get your result as a function of u, you can just replace u with the cosine of z and then put in these original bounds. So that's a choice. You can do it either way. In fact, if you want to try it the other way and check your work, you should still see an answer of 0.